All right, you filled in your table. We're doing 2 to the power of x. So what did you fill in for negative 3? 0.125, which is the same thing as 1 over 8. Good. How about negative 2? 1/4 or 0.25. All right, negative 1. 1/2 or 0.5. How about 0? 1, 1, 2, 2, 4, 3, 8. Good. So whether you did it by hand or you used a graphing calculator, okay, you typed in 2 raised to the power of x, so your variable is your exponent. This is an exponential function, okay? Today we're going to review these. We're going to review transformations with these, okay? The reason why we're actually spending 2 days on this, okay, we'll practice tomorrow on big ideas, is because when we do logarithms, okay, logarithms is the first, like, brand new thing that you've done, right? You've probably never heard of a logarithm before, unless you're in physics, possibly, okay? Logarithms are new to you. So let's take what we know and build off of it, okay? We know exponentials. Logarithms and exponentials, they're inverses of each other, okay? Like right now, if I said 2 to the power of x equals 7 and said solve, you would not know how to get rid of a base. You haven't done that yet, okay? That's what logarithms are going to do for us. So we're going to remember what exponentials are, and then we're going to remember when we do logarithms that everything is just going to be flipped. Okay? So you'll have a little bit more of an idea of what's going on. Something new we're also going to talk about is an asymptote. Okay? An asymptote is a line that your function is going to approach but never touch or cross. Okay? So if I look at the graph of 2 to the power of x, it looks like this. Okay, there's the points that we plotted. If I zoom out, look, what line is it going to never ever cross over? It looks like the y equals 0, our x-axis, right? It's never crossing over it for as far as I go. Okay, that is the asymptote. If you use your handhelds and you go in your table, eventually it's going to tell you undefined. Okay, because the number just gets so small and so close to 0 that it can't even tell you what it is anymore. Okay, like here, if I went down to, like, I don't know, negative 100. Okay, that's 0 point. There's 30 zeros and then 788 is what that represents. Okay, it gets so tiny and so close, but it will never actually equal 0. All right, so that's what an asymptote is, and every exponential is going to have one. Okay, y equals 0 as our x-axis, so we do the equation of the line. Nothing stops it, though, going left and right. So your domain will always be all real numbers. Range is your y values. That's connected to your horizontal asymptote. So the y values will have to be on top of the horizontal asymptote, which is where it was 0. So remember, it can't be equal to, it has to be greater than the asymptote because we cannot touch it. It's like one of those invisible electric fences. Okay? You can get close to it, but don't touch it and don't cross it. Okay? So let's just review some stuff, talk about key features. We'll make this quick and easy. Okay? Our first example was 3 to the power of x instead of 2 to the power of x. So just like last time, if I plug in negative 3 for an exponent, what's my outcome? 1 over 27, which is the same thing as 0.037. All right, how about with negative 2? Okay, which is 1 over 9. How about negative 1? Which is the same thing as 1/3. How about 0? 1. How about 2? I'm sorry. How about 1? 3. How about 2? There you go. How about 3? 27. Okay. All right. Plot these as close as you can. So here we're really close to the the x-intercept. 0, 1 is our first nice point. 1, 3, 2, 9, and then it goes off of our graph. Ooh. Okay. Here's our exponential. It's still flattening out at the x-axis, so we do draw the asymptote with a dashed line like that. So my horizontal asymptote is still at y equals 0. Your domain will always be all real. And your range, your y's, are still greater than 0. If I had to classify this, remember there were two different options? Remember growth and decay? Familiar words? Exponential growth, exponential decay. Which one would you consider this one to be? A growth, yes. How come? The graph looks like it's going up. What about the part of the function? That 3, right, is bigger than 1? Yes? That 3 is called a base. Okay? So when your base is bigger than 1, it becomes an exponential growth. Okay, with exponentials, it is all about that base. About that base. About that base. Okay, that's what you look at to determine growth or decay. You look at the base of the function. All right, let's move on to our next one. 1/4 to the power of x. All right, when you plug in -3, what happens? 64. All right. Brendan, how about when you plug in -2? 16. Zach, how about when you plug in -1? 1/4 to the -1 power. Hold on, it's negative. So it becomes 4. Tamar, how about 0? I gave you an easy one. 1, yep. Connor, how about exponent of 1? 0.25 or 1/4, either one. Julian, how about an exponent of 2? 1/16. Which is the same as 0.0625. Let's see here. Kaylin, how about 3? 1/64. All right, so this one starts really tall and then works its way down. Is it still flattening out at the x-axis? Yes. Are we still above the x-axis? Yes. So those haven't changed, and your domain will always be all real. So we are still approaching our horizontal asymptote, but we are not going to cross over. Okay? So what is our transformation rule? This time we have 1/4, which is my base, and it is now less than 1. So this is an exponential decay. Whoop, can't spell. Y'all, what am I doing? There we go. Okay, so those are like really your two parent functions, the parent of a growth, the parent of a decay. Now we're going to start adding, subtracting, multiplying, throwing in negatives, and just see what they do. All right? The first thing I'm throwing at you is a negative, and I've thrown the negative in the exponents. So let's see what that happens. What usually happens with the negative in a function? It's going to reflect over something, right? So I bet you the same thing's going to happen. Let's see what it's going to reflect over. Okay. 5 raised to the -3 gives us 125. There you go. Good. Riley, what's -2? 5 to the negative negative 2. 25. Good. Shloke, how about negative 1? 5. Bree, how about 0? Mm-hmm. 1. Mm-hmm. Yep, anything to the power of 0, whether it's negative 0 or not. Still just a 1. Ren, how about 1? 1/5. Good. Dylan, how about 2?
1/25.
Mm-hmm. Josh, how about 3?
1/145.
Beautiful. And if anyone's doing decimals, that is 0.2. That is 0.04. And this is 0.008. All right, so we start really tall again. Work our way down. It's more of a jump this time. Negative 1, 5, 0, 1. And then we get itty bitty. Still, though, we're flattening out. Horizontal asymptote did not change. We're still at y equals 0, which means my range is still y's are bigger than 0, and our domain is still all real numbers, like always. Okay? Okay, well, it looks like the one that we just did. So what transformation happened?
Okay.
Nope. My base, though, is still 5, right? Our base is 5, which is bigger than 1, so it's still a growth. So what did the negative exponent do? We expected it to reflect. What did it reflect over? Which axis? The y-axis. Good. Good. So having a negative exponent is going to make us reflect over the y-axis. Okay, so that's why we can't look at the graph and try to classify as growth or decay. It's all about that base. About that base, about that base. Okay. I mean, I've thought about it.
No.
And I think it's a great idea.
Don't do that.
What if I just it's like your walk-in song? Just jamming out to some Meghan Trainor. Right? Yep. Okay. Here we go. Oh, before we flip to the back, let's look at something. These 3 graphs had 4 of the same key features. 4 of the same key features. What were they? They all shared the same horizontal asymptote, the domains. Is that what you're talking about? Okay. The range and the y-intercept. They all had the same y-intercept. So those things, these have not been altered yet. Okay? I know, right? It's like I'm mentioning it on purpose or something. So far, reflection and our parent functions, they all have a y-intercept of 1. Horizontal asymptote is at 0. Range is bigger than 0. And our domain is all real numbers. Okay? So far, those aren't changing. Until. Look at our next one. Look at our next guy. It is 2 to the power of x plus 1. What usually happens when we add something onto the end of a function? It usually bumps it up, right? You think it's going to do the same thing here? Possibly. All right. Well, good thing we already did 2 to the power of x in our warm-up, right? All we have to do is just add 1. So 2 to the negative 3 plus 1 gives us what? It's 1 over 8 plus 1, which is 1.125. Good. Which is the same thing as 9/8. 1/8 plus 1 or 1/8 plus 8 over 8. 9/8. All right, how about negative 2? 1.25. As a fraction, that's going to be, there we go, an exponent of negative 1. 1.5, good, which is 3 over 2. 0. 2, good. 1, 3, 2, 3. Good job. All right, so this time, look at what's happening here. A little bit above, here. 1, 3, 2, 5, 3, 9. Look at this guy. Did it bump up? Yes. Did the horizontal asymptote bump up? Yeah. If I put +1 right here. See how it's leveling off? But now it's leveling off at 1, not 0. Okay? So did it raise everything up? Yes. It raised the asymptote. It raised the y-intercept. It all got pushed up. Okay? Horizontal asymptote is now y equals 1. We're still above it, so we're greater than 1. Domains will always be all real. Okay. So we added a k value to the end of this. This was a base to an exponent plus a k value. So when you add or subtract k, you are going to move graph either up or down. This is going to change the horizontal asymptote. It's going to affect your range, and it affects your y-intercept. Yes? Okay. What's happening in number 5? Now my base is going to be negative. We have a negative base. So let's see what a negative base is going to do. Okay? So what is negative 2 to the power of negative 3? Negative 1/8. What's negative 2 to the power of negative 2? Which is negative 1/4. Yep, I'll put both of them up here again. Stephen, what's negative 2 raised to the negative 1? Negative 1/2. Maddie, how about raised to the 0? There you go. Connor, raised to the 1. Negative 2. Julian, raised to the 2. Negative 4. Rowan, raised to the... Nope, you're right. Because you do 2 squared and then do the negative. Yeah. Rowan, how about power of 3? Negative 8, good. Yeah, so this negative out there, it's like doing negative 1 times 2 to the x. Because there's no parentheses, so yeah, it is separate. Okay, let's see what's happening this time. Now we're going negatives. Does that make sense? Well, we had a negative, right? So we expected some kind of a reflection this time. Okay, a reflection did happen. It got reflected over the x-axis. Did that affect our horizontal asymptote? No, it's still at y equals 0. Did it change my domain? Nope, never will. Did it change your range? Yes, because now they're under. Okay, so this time we have a negative base. It has an a value of negative 1. So this is an a of negative 1. Okay, so when that is negative, oh, I forgot my e. Okay, this is going to reflect over our x-axis this time, and that changed. This changes our range and our y-intercept. Is this a growth or a decay? Which one is it?
It's less than 1.
What's my base, though?
Oh, no.
Yeah, the base is still 2. Yeah, our a value is the -1, so that's separated. The base is still 2. So since our base is still bigger than 1, this is still considered a growth. Okay, it was a reflected growth model. Gotta watch out. Because remember, it's all about that base. About that base. About that base. You laugh at me, but you're not going to forget it. All right, here we go. 2 more. Okay. Speaking of an a value, these both have an a value. My first one has an a value of 5. Number 7 has an a value of 0.5. Okay, so let's see what happens when I have an a value that's a number that's not negative. Okay, because negatives are reflections. So what happens when it's just this number going on? And 5 times 3 to the power of x. We did 3 to the power of x already, your example 1. So that makes it nice and easy for us. We multiply them by 5. What do we get for -3? 5/27. How about for -2? Dion, how about -1? Yep, 1.6, which is 5/3. Quinn, how about 0? Try again. 5. Yep, there you go. You got it. Good. I called everybody. Abidon. How about 1? 15. PJ, how about 2? Try again. Do 3 to the power of 2, which is 9, and then do 9 times 5. 45. There you go. Yep, you got it. Evan, how about 3? 135. Good. All right, so we're starting low again, but then we jump up really fast. 1.6. This is 5. 115, we're already off. Okay. Horizontal asymptote, the same or different?
The same.
It is still the same. So it's still at y = 0. Domain will always be all real. My range, is it the same or different? It's still the same. So we're still y's are bigger than 0. So it didn't affect any of that. So what does multiplying by a 5 do? Yes, my y-intercept definitely changed, right? 5 is bigger than 1, right? Any other function, if you multiply by a number bigger than 1, what transformation was that?
Oh, a stretch.
What kind?
A vertical.
Vertical. There we go. This is a vertical stretch, which is going to change the y-intercept by the a value. Okay. Bonus question, what was your a value in the last problem? -1. What was our y-intercept? Ooh, fancy. See that? Here, a value is 5. Look at our y-intercept. It is now 5. What do you think is going to happen with our last one? You think it'll be 0.5? What kind of transformation do you think is going to happen?
I like gross.
A vertical
Compression.
Shrink, compression. Let's see. Let's see if you're geniuses. You probably are. So how about 0.5 times 2 to the power of x? So now 0.5 is our a value. 2 is our b value. So what do we get with an exponent of -3? Arlington. Yep. Which is equal to 1/16. Thomas, how about -2? 0.125, which is the same thing as 1/8. Zach, how about -1? Mm-hmm. Just 1/4. Kaylin, how about 0? Mm-hmm. Tamar, how about 1? 1. Ren, how about 2? Yep. Connor, how about 3? Good. Somebody today is going to say 3. Somebody. It's going to happen. Hasn't happened yet. 1, 1, 2, 2. Trying to trick people. It's not worked. Y'all are too smart for me. Okay. Start real low, work our way up. Did your predictions come true? Yes, it's not on here, but I'll tell you that 4 goes to 8. So, did your horizontal asymptote change? No. Domain is always all real. Did your range change? No. So, when we multiply by 0.5, what matters is that it is less than 1. So it is a vertical shrink, like y'all guessed. Or vertical compression, same thing. And just like the one before, this is going to change the y-intercept by that a factor. Okay. Now, I did one of each, okay? You know we like to get fancy, and we'll put 2 or 3 transformations into one function, okay? So don't see an a value and think, oh, that has to be my y-intercept. Not true. Because if I'm multiplying by 5, but then I'm also adding 2 on the end, right? Then my y-intercept is now going to be at 7. Does that make sense? So sometimes 2 things are going to happen that changes the y-intercept twice. So just watch out for it. All right? Beautiful. We'll practice this tomorrow, and then we'll do our logs. So everything we did today, we're going to switch it all. So what do you think is going to be all real numbers for logarithms? All of our ranges, yeah. Instead of a horizontal asymptote, it's going to have a vertical asymptote. Okay? Everything's going to be switched.